Good morning. Question number 12. The slope of the tangent to the curve x equals y power 100 plus log 100 power y at the point 3 and 1 equals 102, 100 multiplied 3 power 99, 1 over 102. So the required here is to find the slope of the tangent. And the slope of the tangent equals dy dx. Of course, we will find the slope of the tangent to the curve. If you have a curve like this, so the slope of this tangent, this straight line, here, the slope of this straight line equals dy dx, also equals tan theta. Theta is the inclination angle of the tangent to the positive direction of x-axis. Here is theta. So we have x equals y power 100 plus logarithm 100 power y. So we have x equals y power 100 plus 2y. How we get 2y? Here is logarithm 100 to the power y. It is equal y logarithm 100. And the logarithm 100 equals 2. So we have, it's equal, we have y multiply 2, which equal 2y. So x equals y power 100 plus logarithm 100 power y. It will be x equals y power 100 plus 2y. Log 100 power y equals 2y. Now we're making the first derivative with respect to x. Here, the derivative of x with respect to x equals 1. And the derivative of y power 100 is 100 multiply y power 99 dot y dash. Y dash of course is dy dx, because we're making the derivative with respect to x, plus 2 multiply y dash. The derivative of 2y is 2y dash. At the point 3 and 1, this form will be 1 equals 100 y dash plus 2y dash. Substituting y power 99, here we will substitute y equals 1. So 1 power 91 is 1. Multiply 100 y dash, it will be 100 y dash plus 2y dash. And from that, we will add 100 y dash plus 2y dash equals 102 y dash. So we have 1 equals 102 y dash. So y dash equals 1 over 102, and the solution will be D. The perpendicular to the curve y equals ln x is parallel to the straight line 2x minus 2y plus 3. What is the slope of the tangent to this curve? If you have a curve like this, so this straight line is called a tangent here. Okay, and the slope of this tangent dy dx is the first derivative of the equation of the curve. So the slope of the tangent equals dy dx. And if the slope of the tangent equals m, so the slope of the perpendicular here, the perpendicular to the tangent, equals negative 1 over m. Note that the product of the slope of the tangent by the product of the slope of the normal equals -1. So dy dx, it is the slope of the tangent, equals, here we have y equals x ln x. We have two functions. So the derivative equals the first derivative, the second. First function is x, and the derivative of the second function, derivative of ln x, is 1 over x, plus the derivative of the second function, plus the second function, multiply the first, multiply the derivative of x. The derivative of x equals 1, so the result is ln x. X multiply 1 over x equals 1. So dy dx equals 1 plus ln x. So the slope of the perpendicular to what? Perpendicular to the tangent, equals -1 over 1 plus ln x, according this rule here. If the slope of the tangent equals m, so the slope of the perpendicular at the point of tangency here equals -1 over m. Here in this example, we get the slope of the tangent equals 1 plus ln x. So the slope of the perpendicular equals its reciprocal multiply -1, which equal -1 over 1 plus ln x. Okay. And from the given, the perpendicular is parallel to this straight line. So they have equal slopes. See, they have the same slope. How you get the slope of this straight line? We have straight line 2x minus 2y plus 3 equals 0. So the first derivative will be 2 minus 2y dash, which equals 0. And from that, y dash equals 1. So y dash equals 1. Y dash, it is the slope of the straight line, equals the slope of the perpendicular. So we'll put -1 over 1 plus ln x equals 1. And from that, by cross multiplication, 1 plus ln x equals -1. And from that, ln x equals -2. Ln x equals -2. And we can deduce that x equals e power -2. If ln x equals -2, then x equals e power -2. Remember that if logarithm a to the base e equals x, so a equals e power x. Of course, logarithm a to the base e, it is ln a. Here is the common logarithm, equivalent to the natural logarithm. Common logarithm to the base e here, it is equal ln a. Okay, now we get x equals e power -2. Since y equals x ln x, so y equals e power -2 ln e power -2. And e power -2, here I write it, ln e power -2, it is -2 ln e, and ln e equals 1. So y equals e power -2 multiply -2 ln e. I can write it in this form as ln e equals 1. So y equals -2 e power -2. So the point of tangency is x equals e power -2 and y equals negative 2 power negative 2e power negative 2. This is the point of tangency. So we can say that at the point e power negative 2 and y it is negative 2e power negative 2. The equation of the perpendicular is y minus y1 over x minus x1 equals 1. Y minus y1 and y1 equals negative 2 e power negative x over x minus e power negative 2 equals the slope. It is the equation of any straight line. The equation of any straight line is y minus y1 over x minus x1 y1 and x1 and y1 it is the point of tangency equals m. M is the slope. Okay, here the equation of the perpendicular is y minus negative 2 e power negative x over x minus e power negative 2 which equal 1 not cross multiplication. Now negative multiply negative is positive, so we'll simplify it. Cross multiplication will get y plus e multiply e power negative 2 equals x minus e power negative 2. So y minus x, y minus x here, y minus x equals negative e power negative 2 minus 2 e power negative 2 which equal negative 3 e power negative 2. And we can write x minus y equals 3 dot e power negative 2. Of course, you can multiply by negative 1. So the result is letter A, and this is the solution. Here. Question number 14. The tangent to the curve x equals e power theta cosine theta and y equals e power theta sine theta at the point where theta equals pi over 4 mix with the positive direction of x-axis and angle of measure here. So if we have the curve in this form like this, and here is the two coordinates, again here is the curve and here is the tangent to the curve. The question is to find the measure of this angle theta, and the measure of this angle we will calculate it. I'll use another symbol because here we have theta, so I'll use alpha to express the inclination angle of this straight line at the point of tangency here. Okay, so again m equals tan alpha. M is the slope, as I said before. M is the slope of the tangent equals tan alpha, and the tan alpha equals t dy dx. Of course, if we get tan alpha, we can calculate the measure of the angle alpha. Alpha is the angle, the inclination angle. So how we calculate the first derivative? Here we will use the parametric differentiation. Why? Because x is a function in theta, and y also is a function in theta. So how you get dy dx? Dy dx equals dy d theta divide dx d theta, and dx d theta equals, here back to the equation, here is x. Okay, so dx d theta, here we have two functions, e power theta dot cosine theta. So their derivative equals the first function e power theta dot the derivative of the second, which is negative sine theta, plus the second function cosine theta dot the derivative of e power theta, which equal e dot theta. You can take e power theta as a common factor. So between bracket equals cosine theta minus sine theta. And here is y equals e power sine theta, e power theta sine theta. So again, we will calculate dy d theta. dy d theta equals the first function multiply the derivative of the second plus the second multiply the derivative of the first. So we have e power theta cosine theta plus sine theta dot e power theta, and again I will take e power theta as a common factor. So between bracket we have cosine theta plus sine theta. So dy dx equals e power theta multiply cosine theta plus sine theta over e power theta multiply cosine theta minus sine theta. And we can dividing up and down by e power theta. So tan alpha is dy dx. So tan alpha equals, substituting theta equals here pi over 4. Pi over 4, it is 45 degrees. So cosine 45 equals 1 over root 2. Sine 45 equals 1 over root 2. From here, we can deduce that the denominator equals 0. So tan alpha equals root 2 over 0. It is undefined. So dy dx is undefined. And from that, we deduce that alpha equals 90 degree, which equal pi over 2. Of course, tan 90 degrees is undefined. So the result, so the solution will be in letter D. And we'll choose it. Question number 15. Here we have the slope. Here we have the equation of the curve is y equals ln tan theta plus ln cosine theta. So what is the required? The required is to find the slope of the tangent. The slope of the tangent is dy dx. And again, we'll use the parametric equation and chain rule. dy dx, here dy dx equals dy d theta divide dx d theta. And again, we'll use, we will calculate dy d theta. dy d theta equals, here, we will concentrate here. dy d theta equals 1 over tan theta here dot the derivative of tan theta, which is sec square theta, plus the derivative of ln cosine theta is 1 over cosine theta, multiply the derivative of cosine theta itself, which is negative sine theta. Substituting theta equals pi over 4, you will get this part here equals 2, and the other is negative 1. Note that 1 multiply negative sine theta over cosine theta, it is negative tan theta, and the theta equals pi over 4. So negative tan pi over 4 equals negative 1, and the result equals 1. And we repeat differentiation with respect to x here. The derivative of ln sine theta is 1 over sine theta dot the derivative of sine theta itself. So it will be cosine theta plus the derivative of len cotan theta. It is 1 over cotan theta multiply its derivative. It will be negative cosec square theta. The derivative of cotan is negative cosec square theta. So dy d theta when theta equals pi over 4. Don't forget pi over 4 is 45 degrees. You will substitute here theta equals 45, so cosine 45 over sine 45 equals 1. Okay, because cosine 45 equals sine 45 plus 1 over cotan theta. You can use your calculator. Multiply negative cosec square 45. Here you substitute theta equals 45, and the final result will be negative 1. But the required here is to find dy dx. So dy dx equals dy d theta divide dx d theta. 1 over negative 1, which equal negative 1, and the result will be at letter A. Next question, number 16. The measure of the angle that the tangent to the curve y equals e power tan x sine x makes with the positive direction of x-axis at x equals pi equals. Here the question about the measure of the angle. Again, we have y equals e power tan theta sine theta. So the slope of the tangent equals dy dx, which equal tan theta. So if you get dy dx, you will get theta. So dy dx equals the first dot the derivative of the second, e power tan x dot cosine x, plus the second multiply the derivative of the first, sine theta multiply here the derivative of e power tan x, which is e power tan x dot the derivative of the power is sec square. Directly substitute theta equals pi because required at x equals pi. So we have dy dx equals e power tan pi dot cosine pi plus sine pi dot e power tan pi dot 1 over cosine square pi. Using your calculator, you will get negative 1. So dy dx equals negative 1. It means tan theta equals negative 1. Tan theta equals negative 1. So theta equals tan negative 1 to negative 1. Okay. You can calculate theta equals 135, which equal 3 pi over 4. Here you can use calculator to find theta. How you will get theta? Shift tan negative 1 equals negative 45 plus 180 equals 135. To convert it to the radian measure, you can multiply the answer here. Okay, we have 135 times pi all over 180, which equals 3 over 4 pi. So the result will be 3 pi over 4, and you will choose letter D. Letter D.